All right, guys. So today, really important lesson just for your AP test. They're going to be connecting position, velocity, and acceleration. This time using integrals. So really on AP tests, they're going to be asking you to derive to get these things, integrate to get these things, going back and forth. So let's just do a quick review. So if you remember, we have position, we have velocity, and acceleration. Sometimes I also call this position S of t, and speed, remember, speed is the absolute value of velocity. It doesn't really matter the direction when we talk about speed, it just matters the rate. So in order to go from position to velocity, we got to take the derivative. So how do you think we would go backwards? So if you want to go backwards, instead of doing the derivative, we would do the antiderivative. Or if we want to go from velocity to acceleration, we're going to do the derivative of velocity or the second derivative of position. And once again, in order to go backwards from acceleration, we would have to do the antiderivative. So just so you guys know, in order to go backwards, though, it is going to have that constant integration. So they'll give you some sort of initial value that you'll have to solve for in order to get the original function. Now, some things we do need to talk about is we have a few terms. So we have what's called displacement. Let's just say displacement of x. Well, displacement of x, that's really just the change of x, the net change of x. In other words, x of b minus x of a. The starting or the ending value minus the beginning value, that net change. Where are we compared to the beginning? So another way we can get that is by integrating, because notice x of b minus x of a. So if we were to integrate velocity, well, the antiderivative velocity, wouldn't that be just position from a to b, which is really just x of b minus x of a. So if you want the displacement of x, if you want the displacement of position, you would just integrate velocity from a to b. Now, one of the questions that might pop up is they'll give you something like they'll give you, let's just say, x of 1 equals 3, and they'll say find x of 4. So if you think about that, x of 1, this is like a starting condition because 1 comes before 4. So, and this would be the ending value. So basically, this right here, this represents the end value. And this one right here is like our initial value. So where are we starting? This is where we're starting. This is where we're ending. If it's like a race, this would be the start. This would be the end. So if they were to do that, then you would just, simply just remember that basic formula that the integral of v of t dt from a to b is equivalent to x of b minus x of a. So I just want to clean this up a little bit. So if they were to ask you for x of b or like x of 4, you would just find the antiderivative or integrate, find out whatever you get, area under the curve, whatever that is, and then take this x of a and just add it to the side to get x of b by itself. Or let's say they were to give you x of 4, the ending value, and you needed to find x of a, you would find your integral first, subtract this to the other side, and then divide the negative. So there's different ways around that. We also need to talk about total distance. So I just keep moving this down. So total distance, if we're thinking about traveling, let's just say here's our line, here's your car. So we're in our car driving to, man, that's a horrible car. It's actually facing the wrong way. Give me a second. So I'm in my car. There we go. That's going to look better. I don't even know what kind of car this is, but we're in this car, and let's just say you're traveling to San Diego, and you're traveling that distance. You go total distance that direction of 100 miles, and then your kids start complaining, so you turn around and you're going 50 miles back the other way. So what was our total distance traveled? Well, our displacement, let's talk about the displacement first. Our net change, the difference between our start and the end would really just be 50. It would be that 100 minus the 50. We'd only gone a displacement of 50 miles. But what's the total distance traveled? The total amount of miles you put on the car, wouldn't that be the total distance? Wouldn't that be 150? So if we were to think about this, if you just had a curve, let's say this curve represented our velocity, How would we figure that out? If the area of this curve was 100, telling us that we traveled a distance of 100, this is our velocity curve, and this one is 50, well, our displacement, we'd subtract that negative area, it'd be 100 minus 50 for our displacement of a total of 50 on the displacement. But as far as our total distance traveled, we went 100 miles and then 50 miles backwards. So in order to figure out your total distance, you need to flip that negative part and add that together. It was really 100 and then 50 miles back the other way, a total of 150. So in order to figure out your total distance, there's a formula for it. Really simple formula, but evaluating it can be a little bit of a pain, and we'll have a future video on that. Our total distance would be the integral of the absolute value of the velocity. One last thing to talk about as far as this goes, make sure that absolute value is inside the integral. You don't want it to be this. And I know there's AP questions on this. Because think about our example here. Here the integral comes first. So this would be displacement. Remember, the displacement's the integral of velocity from A to B. Our displacement was 50. You would be taking the absolute value of 50, which would get you 50. Well, that's not the total distance. The total distance, we need to go ahead and do the absolute value beforehand. We need to flip the graph beforehand and then add up those areas. So we need to do that absolute value first and then take the integral of the absolute value of that function. And that's the intro to this, which is a really, really big section, by the way. So make sure you watch it, make sure you understand that, and there'll be a lot of